Welcome to BAS 120, Chapter 1. We're going to go through the second part of Chapter 1, which is going to talk about different types of data for business analytics. So a couple of the learning objectives. We're going to talk about what a metric is. We're going to talk about the four types of data. We're going to talk a little bit about models. We're going to talk a little bit about what an influence diagram is. Now, a lot of this will become more clear as you go through the videos on every example that are in the playlist. So the way the playlists work is I give a summary of the lesson, and then there are videos on every example in the book. So some of this will become more clear as you go through all of this. We'll show some how to compute a model. We'll talk about the difference between uncertainty and risk. We'll talk a little about optimization, deterministic versus stochastic, problem solving. In the break even, you're going to see more in the example. So, a couple of terms. Data or a data set is only a collection of data. A database is defined as a collection of related data. Okay? So, what you have in a database is you have different fields, which can be different types of data. And within each field, you have what's called entities or records. So, for each field or attribute, you're going to probably have several rows of entities or records. But what a database provides is it provides a way to take all the data or a data set and put it into some sort of organization by structuring it into fields or attributes and laying out what each individual entry or record is. Now, a metric is simply a unit of measure and a way to quantify the performance. For example, it's the score of the game, or the revenue or earnings that a business has, or the quality level. A measurement is defined as the actual act of obtaining the data. So the measurement would be the actual score, and the metric would be the number of runs, and the measurement would be 5 if we scored 5 runs. Okay, a couple of type of metrics. We can have discrete metrics, which are called yes, no, on, off. We can have on-time deliveries. We could have pass-fail, where the metric is discrete. You either did it or you didn't do it. Or you can have continuous metrics, like dollars, like time, like weight, etc. Now, there's 4 types of data. And each data is classified by whatever the highest level of attributes it has. So if these build on each other. So all ratio data is interval. All interval data is ordinal. All ordinal data is categorical. And the way you rate it is if it meets all the criteria, you call it ratio. If it only meets the first level of criteria, you call it categorical. So categorical data is where it can be differentiated. It's like a person's name or a region, okay? But it can't be ordered. I can't say John is ahead of so-and-so. I mean, I could order it alphabetically, but I can't order it in terms of who's more or less, which volume is bigger or smaller. Ordinal data puts an order to the data, but the interval between each reading is not the same. So it'd be like a college football team rankings, the top 25 rankings. You can rank them from 1 to 25, but there may be a huge difference between the number 1 team and the number 2 team, and the number 2 and 3 team might be very, very close together. So it's called ordinal data because you can order it, but the interval between each order is not consistent or the same. The next type of data is interval data. That's where the interval is consistent. So an example of that would be time. We have 10 o'clock and 11 o'clock. I can order it, and I know 10 to 11 is an hour. The difference to 11 to 12 is an hour. The difference between 12 and 1 is an hour, etc. The only thing I can't do with interval data is I can't say 2 o'clock is 20% more than 10 o'clock. And the reason I can't do that is because I have no natural zero. So the final level of data is called ratio data. That's where I have a defined zero. So that would be like sales, right? Zero is zero. If you sell 130 and I sell 100, not only can we say you sold more, but we can say you sold 30% more. The next chart just sort of shows how these build on each other. A comment, right? We talked about categorical being mutually exclusive, but you can't order. Order, you can order and rank them, but the difference between each one may not be the same. Interval, there's a constant difference between each number, constant interval, but there has no zero, so you can't make any comparison. And ratio has a continuous and there is a zero. So we talked about examples like eye color, region, college football rankings for interval, time, and temperature. For ratio, sales volume, we can compare. And the reason it becomes very important is we're going to use, when we get into statistics, we're going to use different statistical measures for different types of data. Because if you think about, like take the average, most people know an average or a mean. You could never say what is the average eye color of people in America because it's categorical data. It would be meaningless. So here we have some different types of data, and let's talk about what type of category this would be. So the customer name is exclusive, but you can't order it, so this would be categorical. The customer numbers would be ordinal, right? I can order them, but I'm not sure there's a constant number between each one. Invoice number, the same way, it's ordinal. I might have voided an invoice number, so I can't always say that there's 526 comes next, then 527. So I can order customer numbers in invoice numbers, but I'm not sure the interval between each one is always consistent or always the same. The amount is, and I think the book called these, just a note, I think the book as a typo, it called these categorical and they should be ordinal. So just a note if you, the amount of revenue, the amount, sales amount, that would be ratio because it has a natural zero and I can compare it. The product type, again, would be categorical. It's mutually exclusive, but I can't say the repair product is better than another product. And the date, the invoice date or the sales date would be interval. I have the difference between each interval is the same, but I have no natural zero, so I can't say January 15th is 20% better than January 10th. So hopefully that makes some sense. And this really is going to come into play as we start describing data, and we're going to use different statistical methods for different types of data. Next, we talk about a little bit about a decision model, and I'm not going to go into this in great detail because that's what every single example does. But just remember, a decision model, we could verbally describe something, we could graphically describe something, or we could do a mathematical model or a mathematical function to describe something. And just so you know, most of the time in here, we'll use mathematical models or functions to describe the data. Now, into our decision models, we have inputs, then we have the model, and then we have the outputs. The inputs can be constraints, they can be uncontrolled variables, or they can be decision variables. So constraints are things like, I'm constrained by how much output I can make because I have a machine capacity constraint. I could have uncontrolled variables, uncertainty, like the inflation rate, right? I don't control that, but it may have some influence on my model. And then I have decision variables like my staffing levels. I can control that. I can put that in. I can run scenarios on that. So the decision model isn't complicated. You put your inputs in. You put them into your mathematical model or decision model, and out comes an output. These are examples. Let's talk a little bit about an influence diagram. An influence diagram, the book talks about Some folks use these as diagrams to help them come up with the mathematical equation. For example, in here, unit variable costs and quantity produced, I multiply those together to get my total variable cost. Fixed cost plus variable cost equal my total cost. Let's talk a little bit about the difference between risk and uncertainty. So uncertainty is where we're uncertain what's going to happen. We don't know what's going to happen, right? So I'm uncertain if a plane leaves today at 10 a.m. is on time or not. So uncertainty exists. Now, risk is a consequence of what actually happens. Now, if you go to this example, if I'm not on that plane, there really isn't much risk to me whether it's on time or not. There's only risk if I'm on the plane. So there's lots of things that are uncertain in the world, but it's only a risk to me and a risk to my assessment if there's some sort of consequence of what happens to me. So if I'm not booked on the plane, yes, there's uncertainty, but there's zero risk. Very simply, they also talk about deterministic and stochastic. So one type of model is where the information is known or assumed to be known. The other is where all the information is uncertain. We'll get through the different models as we get into the examples. Problem solving steps the book talks about. So the first thing is to recognize if you got a problem or not, and that's usually recognized between there's a gap between what we actually want to have happen and what we expect. We didn't get the earnings we expected this month, or we had more defects than we expected. And then you define the problem, and in defining the problem, in theory, you want to bring in all or as many of your stakeholders as you possibly can to get their input and their buy-in to what you're trying to solve and how you're trying to get the solutions. Then you structure the problem with goals and constraints. Then this is where business analytics comes in primarily. Then you analyze the problem, right? How do we take the data and drive decisions based on the goals and the constraints? Then we'll interpret the results for making the decisions. We use some human intelligence. We might say the model tells us this, but maybe we don't want to do exactly that. We might want to tweak it a little bit. And then, of course, you implement the solution. So that's kind of the standard problem-solving set that most businesses are going to go through. Here are the terms that you should be familiar with. And they're all in the book. And that's this. And we'll now go through all the examples.